Good morning, participants. I welcome you to the morning session. Today, we have the pleasure of having Dr. Murtaza Hassan with us. Sir is Principal Scientist, Center for Protected Cultivation Technology, ICAR, Ministry of Agriculture, Delhi. And today, the topic that is chosen for deliberation is next generation farming, vertical, hydroponic, and aquaponic farming using AI and IoT for sustainable food production in India. Sir, it's an honor to have you on our platform. You can start about your presentation.
Okay, good morning to everybody. I welcome you all for this online lecture. And the topic given broadly is that what is the modern aspects of protected cultivation, which includes the technology like vertical farming, hydroponics, aeroponics, aquaponics, and then uh, also incorporating the modern uh, engineering technologies like automation, design, artificial intelligence, and Internet of Things. And basically, ultimately, why we are all doing these things for basically for sustainable food production in India. So let me formally welcome you also. I am working presently at Center for Protected Cultivation at IARI, and I am also the professor in engineering division. So most of my masters and PhD students, they are broadly working on this topic, that is what we call smart urban farming or vertical hydroponics and aquaponics systems. Presently, they are enrolled in engineering division, and mostly they are working at Center for Protected Cultivation Technology. So let me go formally with the slides, how will we proceed. So this is the way we will go. That is the, you can see that outline, and we will try to see what is the present status and future prospects of next generation vertical farming, which is the advanced form of protected cultivation. Then we will know about the greenhouse soilless cultivation technology, soilless hydroponics, aquaponics, and aeroponics systems. Then we will also know about that once we develop the infrastructure, how we do the automation with the help of sensors, controllers, and IoT. And then AI and ML based automation, advantages and challenges, and technological and policy issue. Just a minute, I am breaking. Okay. So we are starting with this, the concept of farming. You can see that how the farming can we make smart even with the help of when we are doing the normal horizontal farming, which is the left side picture. If you do the farming with drip irrigation, raised bed, maintaining the proper bed length, bedding spacing, then also we can do the smart farming in the normal horizontal farming. And then when we go for the vertical farming, that you can see in the different picture on the right side, that we are creating the infrastructure so that you can utilize the vertical space. So vertical space is of course free, but then it requires how you will do the vertical farming. So vertical farming, we have to create the infrastructure that up to which layer you want to go. Suppose 6-layer farming you want to do. Then how will you do the 6-layer farming? So we have to create the infrastructure for the 6-layer farming. And then we have to select whether this type of farming is, only thing it is sure that in vertical farming, since we are using multiple layers, we do not use soil. Then because soil is very heavy, its bulk density is very high. So what we do, that we use lighter materials. There are different types of soilless materials available. Then we can go for pure water culture, that is hydroponics. We can go for aeroponics also. And then we create accordingly the infrastructure. And normally this type of vertical farming, the farmers and growers, they do inside some closed structures, which is normally the protected structures, that is, you can say greenhouse, net house. So any farmers or growers, if he is having the greenhouse or net house, shade net, then how he can do the vertical farming? So normally the greenhouse and this shade net house, its total height in our Indian condition, it's not more than 6 meters. Maximum total height is 6 meters. So within the 6 meter, how much vertical uh, uh, layers can the farmers or growers adopt? He or she has to decide. Normally, what we do, that we go for 6 layer or maximum 7 layers farming. 6 to 8 layer is the very common. Up beyond that, we cannot go. So once the grower or farmers go for 6 layer or 8 layer farming, then uh, we have to see that the growers has to create the infrastructure, and then uh, two couple of things are very important, that what are the types of crops he will grow in this vertical farming. So selection of crops is very important. Then, because each layer is impeding another layer, so the bottom layer will have the minimum light. So in that case, what we have to do, in many cases, we have to install grow light in the vertical farming system so that the crop can get sufficient light for photosynthesis. So light management, crop management, infrastructure management, these are the something very important issues in vertical farming. So now I hope that now you have understood that what is horizontal farming and vertical farming. And then of course, vertical farming, we say that it is the most advanced form of protected cultivation. So this is how it looks like. I will show you the further pictures. So see, as I told you initially, that why we are doing all this type of new cultivation and knowing about it, that because our population is increasing, and then also uh, there is a significant growth in population. Also, the urban population is increasing, and um, uh, there is a scarcity of land and water resources, uh, pushing the current food production to limit. And then we require alternative and more resource efficient food production system for the sustained uh, population growth. So this is why we are all learning about the protected cultivation, then its advanced form, so that there can be a higher agriculture productivity for the increasing population. Now, vertical farming, as I have told you, that normally in combination with, if we do it for with different types of hydroponics cultivation, it is proved to be beneficial in maintaining and expanding environment sustainability, food security, especially in the urban areas. The evaluation of protected cultivation has progressed. It started from the basic greenhouse. Now the greenhouse is advanced, and then in the advanced greenhouse, the growers and farmers are adopting vertical farming system that enhance both plant productivity and efficiency in human labor. The literature also says that in this type of vertical hydroponic system, or you can say vertical farming, uh, there is a, you can say, land, water, and energy resource optimization. Because what we have, that in the limited area now, you can grow more crop. And then in this type of cultivation, whether it is hydroponics or aeroponics, what we found that it is very water efficient. This is the most beauty of this type of cultivation, that water efficiency is very high. With very less water, we can produce more. And then of course, when water will be less, so there will be less energy used for the pumping system. So that's why this type of system is what we can say land, water, and energy efficient system. Now coming to the sustainable vertical farming, these are water and energy efficient technologies, and then it's the typical example of precision farming, because all the inputs are properly managed, efficiently managed. Uh, it is also known as controlled environment agriculture, because in the greenhouse and in the net house, in most of the cases, we do the microclimate management uh, for the control of environmental parameters like temperature, humidity, solar radiation. So we have the mechanism to control them. So once we develop the infrastructure, then we go for the automation, sensor, and IoT based management for the vertical farming. And then, as I have told you, that most of the vertical farming models they are based in soil-less, whether we are using the um coco peat or baked clay, perlite, vermiculite. These are the common materials used as soilless. And then if it is pure hydroponics, then aeroponics. So these are the technologies that is used in the vertical farming based protected cultivation. Precision and smart vertical farming, what we say that it is a revolutionary idea that would enable cities to feed themselves. It consists on cultivating plants on buildings, on rooftops, and even on skyscrapers. This technique has already begun to attract farmers to adopt. Many farmers and growers are adopting, and then it can be linked with any green energy source either. Mostly solar energy source are used, but wind energy is also can be used to for the management of this type of vertical farming system. Now, what is the present status of vertical farming technology, especially in our country? See, in our country, the farmers mostly they are uh, growing doing this type of cultivation in greenhouse, and then they are adopting soilless, hydroponics, and aeroponics. The one rough estimate says that out of the total, you can say that protected cultivation area, that is approximately now more than 1 lakh hectare. So the out of that, the vertical farming as such now, uh, it is the total area covered is approximately 5,000 hectares. What the growers are growing, mostly the vegetables, high value vegetables, flowers, nursery, and then most of the systems are open loop type system. It means that open loop type system is a simple system in which the mostly the inputs are not recycled. If the inputs are recycled, it is very good, but then it's require a good management system that we call closed loop system. Open loop type system is simple, so mostly the growers are adopting this system. So in our country now, the farmers and growers are using the simple vertical farming that require, of course, technological thrust, and then uh, not much automation. They are doing simple automations, and then so automation and all IoT or AI based management now it is coming up, but still since this technology are new and they require technical skills, so this is lacking at present. So this slide shows that what is the present status of vertical farming technology, especially for the reference of the Indian farmers. Now, why we are doing this type of study, as I'm explaining also, but in this slide, that what is the future prospect basically. So there is a gradual shifting of greenhouse cultivation towards soilless due to complex many soil-borne diseases and nematode problem. There is expectation that we need a very high yield and quality food expectation from less area. Present generation needs leafy green, high value and healthy vegetables. Now there is a concept of round the year production, that everything that we require now round the year. And of course, on the one hand, there is a problem of soil degradation, soil and water degradation quality. So these are the things that is pushing the farmers towards vertical farming. And then it is found that in this type of technology, there is a very good possibility and scope if you adopt all the modern machines, all the gadgets of automation, and do the integration with artificial grow light. You can, there is a possibility because it's a closed area, so you can enhance the CO2 level also for increasing the photosynthesis. This is not possible in open field cultivation, especially the grow light use and the enhancing the CO2 level. In open field you cannot do, but in a limited space, especially in the greenhouse, net house, you can enhance the CO2 level up to, say, we say that normally the CO2 level is around 400 ppm. So if you increase it to even up to 1000 ppm, then it helps in increasing the photosynthesis and enhancing the food production, and then maintaining the high CO2 with grow light combination, and then leading to increased photosynthesis and high food production inside greenhouse-based vertical farming. So these all things are possible in the vertical farming. And of course, there is a mission of, that doubling the farmer income. So then when the farmers will use this type of technology, then they can increase the income also. Okay. So once you have the infrastructure, then there is another technology for management of vertical farming, and that is what we call IoT. It is the Internet of Things. So Internet of Things is now very common technology that is used in now all possible area like health, industry, logistics, transportation, agriculture. Now in agriculture, mostly the area of precision agriculture, especially for the management of smart irrigation, microclimate control, IoT is very popularly used. So as the name suggests, IoT requires two very important core things of IoT. One is, at the name of Internet of Things, IoT requires some internet connectivity, okay? Either by data or by Wi-Fi, and by some local Wi-Fi also. And then IoT, for the core thing of IoT is the sensors. How IoT gets data and management, that with the help of sensors, with the help of regular data and then internet connection, the IoT is managed. So this is how you can see now that IoT is now very popularly used in many features, including the precision agriculture. This is the IoT application in precision agriculture and vertical farming. In the case of livestock monitoring, drones, precision farming, then the greenhouse, especially the microclimate control. So these are the areas where now IoT is used for the basically management and supervision of your entire system. This is the core use of IoT. As I have told you that IoT requires sensors. What are the sensors that is used for vertical farming? Mostly these are the type of sensors, that whether it is moisture sensor, cultivation sensor, climate monitoring sensor, disease monitoring sensor, nutrition deficiency sensor, fruit bird. So these are the different, you can say, that sensors that are used for the smart vertical farming and its management. So this is one of the smart urban vertical farming project. This project is funded by Department of Science and Technology, and then this project was basically based on smart urban farming, in which two German institutes worked with IRI, and then we created the vertical farming facilities at Center for Protected Cultivation Technology, IRI, and then all the infrastructures that are required for 1,000 square meter greenhouse, then all the sensors, then controllers, and all these things we could established under the this type of funding by Department of Science and Technology. And then in this project, not only the academic institutes, but our industry partners are all over also involved. And then we basically tried for the because this type of technology is a new technology, so we first of all created a state-of-the-art infrastructure, and then not only the greenhouse but also the other things required for the greenhouse. I am just taking 1 minute break. Online class. Okay. So once we develop this type of infrastructure, and then how the smart urban farming looks like, I will further explain to you. Then these are the, you can see that these are the facilities that we have created at in Center for Protected Cultivation Technology, IRI. You can see in the picture that first of all, you are seeing a climate controlled greenhouse of 1,000 square meter. And inside this greenhouse, if you see that you have a multi-layer system for vertical farming. So as I have told you earlier, we went up to maximum 7-layer farming, 7 to 8 layers, because beyond that, it is very difficult to manage. And if you see in the picture, most of this infrastructure, they are based on soilless, hydroponics, aeroponics technology. And there are different types of frames that are used. There are flat frames, there are A-type frames, there are grow towers. So these are the different types of frames that are used for growing the crops. Each of the frames are controlled by their own water and nutrient management system, which is recyclable. There are the provision of microcontrol and also light management. And here mostly we are using the sensors for microclimate control, for fertigation control, irrigation control. So these are the sensors that are used for maintaining the crops. And in this type of system, especially, the result shows that the green leafy vegetables, which is of that gives very good results. So there are different types of green leafy vegetables like lettuce, bok choy, then you have coriander, now you have mint. So there are different types of lettuce itself is of many types that you can grow. Bok choy is a very broad crop that you can grow. So now you have the varieties of this type of green leafy that you can grow this crop almost around the year. So you have the combination of crops and then crop cycles, so that you can grow this type of green leafy crops around the year. So this is the, you can see in the picture that all these are IoT and sensor operated greenhouse vertical farming, and focusing on one of the standard size of 1,000 square meter greenhouse, because this is the standard size that is used by most of the Indian farmers and growers. So this is the facility that we have created at the Center for Protected Cultivation Technology, IRI, for growing different types of crops inside the vertical farming. These are the, you can say, minute details of the each system. Whether if you take the systems in the greenhouse vertical farming, it is a different types of frames are there. How, if you can say, below this frame there are tanks are there for its management. Each frame takes care of about 200 to 300 crops, and they are 7 to 8 layers, and they are um, different shapes, different spacings are there according to the type of crop. Like you can say, you have, in the picture there is a 12-channel A-frame structure, around 200 plants are there, and we have the sensors of pH, temperature, electrical conductivity, TDS with IoT controller. So these are the different types of, you can say, indigenous type of models and prototypes that we have designed and developed at IRI, and especially suiting to our conditions. They are uh, usually very tough system, and then uh, once you, it is very easy to manage. Only thing is that initially you have to take care of these systems, and then they require regular monitoring, especially in terms of its water and nutrient management. Otherwise, the rest of the things are it takes care of. Now, another technology that is coming up, that is a modern technology, is that how you are using the uh, modern technology like after IoT, that if you use the technology like AI, how to, AI to be used in greenhouse-based vertical farming. So you know that it's a powerful tool that is has revolutionized not only the other sector, including agriculture. The only thing is that AI-based modeling, they are based on machine learning, and they require actually lots of data. And how the data will come? Anything. So the data will come only from the uh, uh, data will come with the uh, sensors. So if you suppose if you are taking temperature data, now manually you cannot take more than, suppose one person cannot take more than 30 or 40 times data. But uh, with the help of sensors, you can take more than say 1,000 data there. So that's why that is the advantage of sensors, that you can use this sensors in for taking generating data. So we require first of all huge data, whatever type of data, irrigation data, crop data, uh, climate data. Then only you can go for the AI-based modeling. So AI-based modeling, it requires a good amount of data, and then we could find that it gives uh, very accurate predictions of crop growth and yield outcomes, especially in comparison to the statistical models. So this is the many studies have been done related to it by our masters and PhD students. They do the modeling for crop growth, for irrigation, and all these things for the vertical farming. You already know about these things, that how AI is now useful in the terms of uh, how it is uh, growing, and then what is the special characteristics of AI. So these things all already know. Just I am presenting it in the slides with the reference. But ultimately, as I have told you that once you do the AI-based modeling in the protected cultivation, all these things, then you require huge amount of data that is required for the modeling. So these are the some small models that we have developed, especially for the common citizens and growers, that whether it's a grow bag type technology, aeroponics, hydroponics, these are the vertical hydroponics. So these are the small systems that models that we have developed that can be used in inside the greenhouse also, and then without the greenhouse also. These small models can be used. Of course, they cannot be put in the directly in the open field, but even if you do not have the greenhouse, then either in the rooftop or in the balcony or in the small shaded area, you can put these small models. So these are the small models, basically all based on hydroponics, aeroponics for vertical farming, and then it can be adopted in a lower small scale for the family-based models on individual level. So these are the some Recently, we have developed one very big project on aquaponics. So it is on also the project titling is sensor-based integrated vertical farming for horticulture crops and aquaponics. So this is the project that we are at presently doing. Another focusing on the new aspects that in the vertical farming we are doing aquaponics also, in which we are growing the fish also. So how with the fish-based system and then integrate it with greenhouse and hydroponics. So all these special models and infrastructure we have created at IRI, and then Indian Institute of Water Management, CIFE Mumbai, IIB, they are our project partners. So we are also doing this thing. So
Thank you so much, sir. Thank
yes,
you all.
no, there are some slides are left. Now let me complete.
Okay, sir. Sir, please try to wind it before 11.
Yeah, before 11, I will complete.
Yes, sir.
No
Thank
problem.
you.
So this, you can see in the picture, these are the IoT-based smart aquaponics systems. And then this is how it looks like. There is a bottom fish tank is there. And then on the bottom, the top, we have the infrastructure for hydroponics. And this is how this type of systems we have created at IRI. This is how after the infrastructure, then we go for the IoT-based management. This is the IoT-based aquaponics system in which, as I have told you, that we are growing the fish and plants together. Now, what last few slides that why we are doing, because ultimately advantages of vertical farming that increase and sustain crop production, protection from weather-related problems, environment friendly, growing higher quality produce, conservation of resources. Everything has challenge also. It is not that it is there is what are the challenges? Challenges that we require indigenous and cost-effective models, integrated approach. We require lots of sensors. Then for any grower, they need trainings, demonstrations, and then presently the policy of government is on protected cultivation, but it is there with the different policies now. The vertical farmings are also being included. So these are the few challenges from the, you can say that from the Indian context. These are the few bulletins that we have developed. These all bulletins are available free. If you will just type it, you will get in the Google free. This bulletin is on hydroponics technology. You will get all the knowledge about hydroponics. This bulletin is about the smart urban vertical farming. It is available both in English and Hindi. You will just type it. You will get it free in the Google. Its title is Smart Urban Farming, and also in Hindi also. So coming to the last slide, that basically we are doing this type of modern protected cultivation technology with the help of vertical farming to increase the crop production with less use of water. We can incorporate the modern technologies like the AI and IoT, and then the overall aim is basically to sustain production and increasing the income of the farmers. So these are the, you can say, salient advantages of the system also. So thank you very much. This is from my side. So now I am closing it. So I'm expecting that if you have some questions, please you can have the questions, please. Anyone from organizer? If you have any question, you can raise it. So I think there is no question. Thank you very much. I'd like to thank, yes, Dr. Ishtiaq. Dr. Ishtiaq, you want to ask something? You have raised your hand.
Participants, if you have questions, please ask. Turn on your microphones and start asking one by one.
You can unmute and then ask.
If not possible, please drop your questions in chat also.
Yes, you can share the question, then I will try to answer. Okay, I would like to thank the organizer. Thank you very much. Thank you.
Thank you, sir, for being and sharing this
Thank you. Thank you.
presentation. Thank you, everyone.
Thank you. Yes, Sandeep.